Humans have always had a crazy urge towards old things since the time of evolution. Isn't it so fascinating when archaeologists say these fossils are 100,000 years old, or this dinosaur bone could be 1,000,000 years old? How do archaeologists determine the age of a fossil that ranges from just over a few years to billions of years back? How do they calculate, and what are the methods used to find out the age of a fossil? First, what are fossils? Fossils are the remains or just traces of remains from the past dead organic matter like bones, shells, teeth, etc. Some may age back to a few years and some may be to millions of years. There are various methods to determine the age of these fossils, out of which these two methods are the most commonly used: relative dating method and absolute dating method. The relative dating method is comparing one fossil to another fossil and determining the age. But on what measure? For example, if we look at the Grand Canyon, we see these horizontal layers, which are nothing but layers of rock and sand getting deposited on each other over a period of time. These horizontal layers are called strata. This process of layering sand horizontally, one over the other, takes a long period of time, usually hundreds to thousands of years. Let us assume we have some fossils underground. We know that the fossils on the top layer are the recent ones, and the ones at the bottom are the oldest, as new layers are formed over it. We already have fossils belonging to each layer. Let's consider that we have discovered a new bone from the third layer, so by relating the bone to the shell of the same layer, we could presume that the bone and the shell belong to the same age. This method is called the relative dating method. The other method is the absolute dating method. Using this method, archaeologists are able to determine the numerical age of the fossil itself. We know that all elements are made of atoms. In order to understand this method, we need to go a little deeper into these atoms. Let us take the element carbon, for example. Carbon has 6 protons and 6 neutrons. This carbon is called carbon-12 or C12, which is a sum of protons and neutrons. The carbon atoms, which has 6 protons and 7 neutrons, are called carbon-13, and the ones with 6 protons and 8 neutrons form carbon-14, C14. So, atoms with same number of protons and different number of neutrons are called isotopes of that element. Here, C12, C13 and C14 are called the isotopes of carbon. C12 and C13 are stable isotopes, but C14 is an unstable carbon. This unstable C14 is radioactive, and when they decay, one neutron gets converted into a proton, which makes the number of protons and neutrons to 7 each, making it a stable nitrogen N14 atom. This process of carbon-14 becoming nitrogen-14 is called atomic decay, and the time taken for this is 5,730 years, and this duration is called a half cycle. Why is this called a half cycle? Because when C14 decays to N14, only half the original sample of C14 remains in the organic matter. So, after 5,730 years, only 50% of the C14 remains in the bone. After 11,460 years, only 25% of C14 remains, and after each half cycle, the amount of C14 keeps decreasing by 50%, and around 70,000 years, there is less than 1% of C14 left over, and it becomes very hard to detect C14 in the bone or any other organic matter, thus making it impossible to determine the age beyond 70,000 years. If we cannot trace back carbon for more than 50,000 years, how do we trace it back to millions of years? Well, every atom has unstable isotopes just like carbon. the half-life of carbon is just 5,730 years, but whereas half-life of potassium-argon is 1.25 billion years. Using potassium-argon dating, we could determine the age range from 20,000 years to 4.5 billion years. But potassium-argon dating can be used only in minerals and rocks. How do we determine the age of bone using potassium-argon dating? We take the help of relative dating method. If we could determine the age of the rock right next to the bone using the potassium-argon dating method, then we could determine the age of the dinosaur bone, which also belongs to the same strata. Then we could presume that the rock and the bone belong to the same period. By combining various methods like carbon dating, potassium-argon dating, and relative dating methods, archaeologists calculate the age of any fossil buried underground for over millions and millions of years.